Hello and welcome to Maths with Jacob. This lesson will focus on division of polynomials. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. Division of polynomials. The strategy for dividing polynomials is similar to the one used when doing long division with numbers. Let us look at an example. Let's look at example 1 where there is no remainder. So we're going to work out this polynomial here divided by x minus 2. And let's see what happens. So in a normal long division fashion, here is x minus 2 divided into that polynomial there. Now I'll go through this one here in a bit of detail just to give you an idea how it works. I'll just do that for this first example. X divided into 4x cubed goes 4x squared. Then you multiply 4x squared by x minus 2 and you get those two terms there. Now you do a subtraction, so it's those two terms there minus those two terms there. So that gives you minus 19x squared. After you do that, you carry down the 50x. So there it is there. That's all we've done. That's why I have the arrow. So you carry the 50x down. Now let's go again. X divided into 19x squared, that's minus 19x squared. So x divided into minus 19x squared goes minus 19x. So you multiply minus 19x by x minus 2 and you get that line. Now let's do subtraction again. 50x minus 38x is 12x. You carry the minus 24 down. Let's go for the division again. X divided into 12x goes 12. 12 times x minus 2 is 12x minus 24. We do subtraction, that's this line, minus this line gives you 0. So there is no remainder. So what that means is that these terms here, that expression, divided into that polynomial goes into it evenly. So up here, the polynomial divided by x minus 2 is the same as x minus 2 times the answer, but this answer here can be factorized as 4x minus 3 times x minus 4. So the full answer is x minus 2 times 4x minus 3 times x minus 4. Also, with example 2, you can have a remainder, just like we do with numbers, that doesn't always go in evenly. So there can be a remainder. So let's have a look at this example. We have this polynomial here divided by x minus 3. So I've set that up here. So x minus 3 divided into that polynomial there. Now we just go through the similar steps very slowly, and I've outlined them here for you very simply. And when you do that, so you just do that at your own leisure, you can stop the video and go through that at your own leisure, you will find that the remainder is plus 27. In other words, the initial polynomial is x minus 3 times 4x squared minus 5x plus 15 plus 27, which is the remainder. So if you don't get 0 here, that means you have a remainder, and there it is there, plus 27. A nonlinear divisor. The divisor may be an expression with a degree greater than 1. That is, not linear, so it doesn't have to be linear. So here it is here, look. X squared minus 4x, so that's a power of 2 there, so it's not linear. So we can divide that into our given polynomial. Again, we slowly go through the procedure. I've got it set up there very clearly. You keep bringing your terms down as you have to. That's why I've got the arrow. So after you do the division, you'll have this answer here. There it is there. And that's your remainder here. So the initial polynomial is x squared minus 4x by x squared plus 6x plus 14, which is there, plus 38x plus 5, and that is your remainder. Now we have a very, very important theorem here to do with polynomials, and it's called the remainder theorem. Consider a polynomial denoted by px. The remainder theorem says that if this polynomial is divided by x minus b, then the remainder is pb. Let's look at an example. If px is x cubed minus 3x squared plus 4x minus 5, find the remainder when px is divided by x minus 2. Now the theorem says P2 will give us the remainder. So you substitute 2 into that polynomial there, and that's exactly what I've done here. When I do simplification, I get to that line, and guess what? P2 is negative 1, so this is the remainder. The factor theorem. Consider a polynomial denoted by px. If pb equals 0, then x minus b is a factor of the polynomial px. Let's have a look at this by doing an example. Find the factors of px equals x cubed minus 6x squared plus 11x minus 6. The initial procedure here is to use trial and error. So we're going to try and find a number where we have 0. That is, when we substitute the number, we're going to try and look for 0 as an answer, and that's going to help us to find the factor. So let's try p minus 1. So we're substituting minus 1 into the initial polynomial. I've done that there very carefully. I've simplified to get to there. So p minus 1 is minus 24. Hence, x plus 1 is not a factor. So let's now try p1. So we substitute 1 into the initial polynomial. That gives us that. Simplified to give us that. And guess what? p1 equals 0. Hence, x minus 1 is a factor, because that's what the rule says. So once we have found this factor here, then we can go through our division process. So to find the other factors, divide px by x minus 1. So x minus 1 divided into the initial polynomial. If we go through our procedure very carefully, look at this, no remainder, and there's the answer. So x squared minus 5x plus 6, if we factorise that, we get x minus 2, x minus 3. So px can be factorised as x minus 1 times x minus 2 times x minus 3. And these are the factors of the polynomial. So basically, 1 is a solution, so is 2, and so is 3. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle, what is the meaning of the following? Highway overpass. Very interesting, isn't it? Here are the answers to the quick quiz, and the video is at your disposal.